Good evening, ladies and gentlemen. My name is Dr. Lizeka Casamba. I am your facilitator for this semester. I'll be taking you through simple interest. I've prepared work on simple interest and discount because these two needs to be looked at simultaneously if you want to understand what is going on. And then I have prepared something for compound interest if we've got time. Okay, so what I'm going to be highlighting, remember, my work is not to help you with your assignments, but to help you to understand how to do your assignments. So it becomes your responsibility if you've got a specific question that you find problematic in your assignment to contact me so that I can be able to help you. Okay, so we are looking at the simple interest and the simple discount. So on the topic of the simple interest, the things that you need to know, um, the basic concept of simple interest together with the simple discount. Okay, so the critical aspects that you need to know when it comes to simple interest, it is the word interest, the simple interest, the principal or the present value, the term, the interest rate, the amount or the future value, the due date, the timeline, simple discount, discount rate, nominal or face value, number of days, and so on and so on. So these are the important aspects that you need to know when we are talking about simple interest. So the critical aspects, ne? So the critical aspects, I named these ones. I'll be highlighting what makes these things difficult is the wrong application of the formula, is the substitution, the actual mathematical substitution. The calculations, people always get the calculations incorrect, translating from the word problems to mathematical expressions, and then there's an aspect of time, months, and years. Okay, so the simple interest, we are going to be looking at the terms. What is an interest? There's a difference between an interest and an interest rate, guys. Okay, an interest is the amount that you get over and above. Let's say you've got 100 rand and your interest rate is 10%. Okay, so 10% is your interest rate. The interest will be the extra amount that you get. That means if ever you've got 100 rand and then the interest rate is 10%, you're going to get 10 rand extra, the rands. That is an amount. There's a difference between those two. Most of the time you find that people will go and calculate interest rate instead of calculating an interest. Okay, there is the principal and the principal value. There is a term of a loan whereby you are looking for the time whereby your loan or your investment is running. And also we've got what we call a future value or the sum accumulated. So what we'll be doing today is to look on how we calculate these aspects. Okay, so most of the time you find that even if you can go to Google, you find that the simple interest is described in this form. You've got these notation that describes the simple interest. Okay, PRT. Okay, whereby your P is your principal and your R is your interest rate and your time is like in years. It's always put in years. Okay, so another formula for the simple interest, it is this one, whereby you've got an accumulated amount which is equal to P into 1 plus RT. So you need to be able to see the difference between simple interest, identify the simple interest, the discount, and the compound interest. What is also important is the interest rate is calculated per annum. Per annum, that means yearly. Okay, should you find that your interest rate is given in times that are less than a year, maybe a month, you need to divide that unit with the number of months. For an example, if ever your interest rate is quoted in months, you need to divide that amount that you're given with 12. If it's quoted with weeks, you divide that with 52 weeks. If it's quoted as days, you need to divide that by number of days in a year. That is 365. Okay, so the formulas, here are the formulas that we are going to be working with. The interest rate is equal to PRT, okay? And we also have what we call the sum that is accumulated. The sum that is accumulated, that is your future value. In some context, it is written the principal value. The principal value is the future value is the principal is the principal plus an interest. That's one of the formulas that you can use. And also you've got this formula which is for future value. This is also future value. I'm just using different notations. This is yet another formula for the future value, or this is the formula for future value. So you've got those three formulas that you use. Even when you are doing amortization, you are using this amortization. You do use a simple interest for amortization. When you're doing annuities, we are going to be doing a compound interest. So now we are focusing on simple interest. So now that's the only thing that you need to know about the theory behind simple interest. What you need to take forward is how to calculate. So I'm going to help you and take you through the mathematical way of thinking, any problem that you come across. Okay, so this question is saying now calculate the simple interest. It is clear, it is telling you that you need to calculate the simple interest and the sum accumulated. Remember, the simple interest is not an interest rate here. You are asked to calculate for I here. Okay, I am decontextualizing what I'm given, and the sum accumulated. The sum accumulated will be your future value. I am using S. Maybe in some texts you find that it's written future value. It does not matter as long as you understand the context that we are talking about. And then for the sum accumulated for 5,000 borrowed for 90 days. So now this is 4. And as you are reading this English can be problematic at sometimes. But as you are reading this story, you can see that you are asked for a sum accumulated for a specific amount. So it's a sum accumulated for an initial amount of 5,000. That means this becomes your principal value for an amount borrowed for 90 days. Okay, look at this one. You are given the time. The time is given not annually, it is in days. Remember, we said if ever the period is shorter, is shorter than a year, you need to divide that with the unit of that or as it is given. So we said the days, there are 365. There are 365 days in a year. So you're going to divide your time with 365. And at a simple interest rate, here's your interest rate. Your interest rate is equal to 0.15. Okay. So now we need to calculate two things here. So I call this a global approach. A global approach is where you are analyzing what you are given and decontextualize. Decontextualizing is to put everything into variables. That's what I have done here. Once you've got all of your variables, you know what is it that you are given and you know what is it that you need to calculate. So now, what is it that you are asked to calculate? You are asked to calculate we are going to start calculating our simple interest first. Okay, so our simple interest, okay, so our simple interest, which is going to be the interest that you are going to get, our simple interest, remember, it is P RT. Okay, so we do have our P, it is 5,000. Okay, so now we've got 5,000. Our R is given as 0,15 and our T is 90 over 365. Okay, once you've got all of your variables in order, you just plug in everything, and then you are going to get that your answer, you plug into your calculator, your answer is going to be 184,93. That is your simple interest. Okay, and also you are asked to find the sum accumulated. The formula for sum accumulated, remember we've got 2, so your sum accumulated is equal to P into 1 plus RT. Okay, this is RT, that is for the sum accumulated. So what is your P? Your P is given as 5,000 into 1 plus your R is 0,15, and your T, you use the very same T, which is 90 over 365. So I am applying the idea of substitution. Okay, making sure that you are substituting everything correctly, and then you just plug in this in your calculator. You'll find that your accumulated amount is going to be 5184,94. Okay, so you've got your sum accumulated, you've got your simple interest there to get, or if ever you started, sometimes you will start with this calculation. Okay, so if you started with this calculation, remember we are saying your accumulated amount, going back to your formulas, it is P plus I. Okay, that's another way you can say. Okay, so you can say here I've got my simple interest is equal to P plus I. Okay, so now if ever I've got 5184,94, my principal is equal to 5,000 plus I. This is another way. You did not have to, you did not have to start with this. You could have started with your accumulated amount. After you get your accumulated amount, you can like do substitution, and then you can say your interest there. If you make I a substitute to the formula, so your interest is going to be equal to 5184,94 minus 5,000. So you would get that it is 184. So it will depend on how the question is asked. Okay. So this is another way of doing your calculation. Let us look in another example. Here you are asked to calculate the present value. So now we are going to break this thing down. We need to calculate for the present value, okay, of a loan issued today with its maturity value, that is future value of P. That means we are looking for S. Our S is equal to 12,000. We are given a future value here in 2 years' time. So the time is equal to 2. So your T here is equal to 2 if a simple interest rate is 12%. So the simple interest rate here is equal to 12%. So now you've got your 12% there. So what we are doing here is to decontextualize everything. Okay, so let us write our formula. Remember our formula, you've got your S is equal to P into 1 plus RT. Why are you choosing this formula? You are choosing this formula because you are guided by the keyword of simple interest. So hence you are using this formula. So your S is what has been given to you. It is 12,000. So you substitute for your 12,000 there, which is equal to your present value is what you are looking for. That is your present value. So you are looking for your P into 1 plus your R. is 0,12 and your t is equal to 2. Okay, so what you would do here, you're going to have your p, take your calculator, you multiply 0,1, 2, multiply by 2, okay, plus 1, you will get an answer of 1,24, okay, which is equal to 12,000. Okay, so you make P a substituted formula. So your P is going to be equal to 12,000 divided by 1.24. So your present value is going to be equal to 9,677 rands, 0.62. That's one example. Let us look on another example. Here is Jojo. This person deposits. Read the text. You know, English can be problematic. We are also struggling with it, even ourselves. So just read that context. Jojo deposits, that is modern graded English. Deposits, that's a present tense. So that means your P is equal to 30,000. This is what he's doing now. He deposits 30,000 into a bank account that pays a simple interest rate. So you are given a rate of 0,075. I am going to emphasize something here. Most of the time you find an error whereby people would convert this 7,5 as 0,75. So be careful not to get into that misconception. It's error is an error because your mind is thinking so quickly. You think 7,5, it is 0,75. So if ever you want to see, if ever you are not you are calculating in a correct way, just put 7,5 divided by 100, you'll get 0,075 per annum. So how many years must he invest for to generating to the future? So it means your future value here is equal to 45,000. And then how many years? You don't know the years, you are looking for the years. So here you have decontextualized all of your variables. Now you need to get your formula. The formula for a simple interest. Why? You can see this is simple interest. So now you're going to have the simple interest is equal to present value into 1 plus RT. Okay, so your future value, you've decontextualized it. It is 45,000. So you've got your 45,000 is equal to your present value is 30,000 into 1 plus your R is 0,075. You are looking for T. You just substitute. Remember, one of the things that are problematic in mathematical reasoning or thinking is the substitution. So you divide both sides by 30,000. So you're going to have 45,000 divided by 30,000. This should be 30,000, okay, which is equal to 1 plus 0,075 t. Okay, so now you find that your left-hand side is going to be 1,5. 1,5 is going to be equal to 1 plus 0,075 t. Okay, so you're going to have 1,5 minus 1 is equal to 0,075 t. Okay, you move this side. So 1,5 minus 1 is going to give you 0,5, which is equal to 0,075 t. You divide both sides by 0,75. You are going to have 0,5 divided by 0,075, which is equal to T. Then you plug into your calculator, you find that your T is equal to 6,67. Okay, so now that is your time. So the value of your time, it is T, 6,67. So I've just taken you through on the mathematical way of communicating. Okay, so let's say you are given yet another example. The example is saying, at what simple interest rate should Lala invest if she wants to grow 25,000, 2.5 to 4,000 in 5 years? So remember we said the reason why we are doing these things, we've got a formula of simple interest, which is equal to P into 1 plus RT. Okay, so now we are calculating for each and every one. We are calculating for P. It's either we are calculating S, or we are calculating R, or we are calculating T. Right now, we are looking for I, for R. So now, at what simple interest rate? So you are looking for R. That's what you don't know. Should Lala invest if she wants to grow these two? So this is starting, this is ending. So now you've got your P is equal to 2.5, and your S is equal to 4,000, and then your T is equal to 5. Okay, so you have decontextualized everything. Go and substitute it into your formula. You've got P into 1 plus RT. So your S is 4,000. Your P is 2.5 into 1 plus your R there is what you don't know. Your T there is 5. So you have that a formula. You divide both sides by 2.5. So now we are going to have 1.6 is equal to 1 plus 5R. Okay, and then you're going to have 1.6 minus 1 is equal to 5R, and then you do you play around. I mean, 1,6, this is going to be equal to 0,6, which is equal to 5R, and then we move here. So your R is going to be equal to 0,6 over 5. So therefore your R is going to be equal to 0,12. That is 12%. So now we have looked on another component of the component of R. Okay, let us look now on a different context. Ne? This is a story. The reason what makes these calculations look difficult, it is there's too much story. Okay, you need to be able to understand what is going around in the story. So once the story looks complicated, draw a timeline. Okay, let's say here you are given here. Let's say when his son was 6 years old, Metuli made a deposit of 6,000 in the bank. The investment grew in a simple interest rate, and when Metuli's son was 18 years old, the value of the investment was 11,100,000. At what rate was the money invested? Give the answer correct to one decimal place. There's too much English taking place here. You can get lost. Okay, so hence the suggestion is go and draw the timeline. Okay, so Metuli has got the sign. So he's starting here. Okay, he's starting here when the son was 6 years. Okay, so your T1 is when your son was 6 years. He is depositing 6,000. That means this is a present value. The present value is 6,610. Okay, and then when the son was 18 years, okay, the value of the investment was, that means somewhere here. Okay, so this is Tn, the son is equal to 18. Okay, and this is it has grew. That is the it has accumulated. That means your S now is equal to 11,000 131,24. Okay, so what else that you are asked to calculate here? You are asked to calculate your R. Okay, and then you ask yourself, what is the formula for the simple interest? Our formula for simple interest is equal to P into 1 plus RT. Okay, you've got your S, you've got your P. You don't know your R. Do you have your T? Your T is given, but it is given with reference to your starting point when the sun was 6 and when the sun was 18. What is a common misconception here that I'm going to point you towards is most of the time people said, okay, this investment has run for 18 years, therefore my T is equal to 18. Then they go and substitute and then they get the answer. Many times you will get the option correct. You will have the option in a multiple choice and think you have made it. However, in this instance, this person, the investment started when the time was 6 and then it ended when the time is 18. You need to calculate. You don't calculate the number of years of Methuli's son, but you want to know how long did the investment grow? How long did you put your money in the bank? So the time that the money grew, the money grew when this one is 18 minus 6. You want to know, you don't care about the age of the son, but the son's age gives you a referencing point. So then you can be able to calculate the time of your investment. Okay, so now the time of your investment is when Methuli's son was 18, but it started when it's 6. We want to get the difference between those two. So the difference between those two would give you the length of the time that this was invested. So it was 12. So now the investment was 12 years and not 18. All right. So now once you've got all of the variables, you're going to have your S is equal to P into 1 plus RT. So you've got your story first in the timeline. The timeline helps you to see what is going on. So your S there, it is 11,131,24, which is equal to the present value, it is 6,610 into 1 plus, you don't know your R, but your T, you've just calculated it because it was implicitly given to you. So you've got that, and you are going to divide both sides by 6,610. And once you do that, you are going to get your answer that your R is equal to 0,057, which is similar as it is equivalent to 5.7%. So the timelines are very important. When there's too much story, that is difficult for you to understand, write the timeline. Okay, so the timeline is something that looks like this, especially for a simple interest. You find that the timeline, it is just you start with your present value. There's one term, and then the formula, which is your future value. It is like this. We do this even for discount. We do this even for compound interest. Now, let us go and look into the simple discount. Simple discount and simple interest, they are looked in the similar way. So, with a simple discount, you need to explain what is a discount and what is a discount rate, and also what is discounted. Okay, what is discounted or a present value? These are the keywords that you find, or a future value. We need to interpret the formula and translate it into timelines. Okay, the interest here with the discount, it is calculated in the future value. Remember, with the simple interest, the interest was calculated in the present value, but with the simple discount, the interest is calculated in the future value. Okay, so here, what I've done here in this screen, I have put these against each other. I have put the simple interest and the simple discount against each other, so then you can be able to see the difference between the two. Okay, so we've already attended to simple interest. The discount will be this. Remember, when we are talking about simple discount, we are talking about the amount. So it is the future value multiplied by the discount rate and also the time. Okay, so the present value, this is how it's written. The present value is equal to the future value minus the discounted amount. And then the components, the variables for the formula for the simple discount, you've got the small nyana d, which is your discount rate. You've got S, which is your sum accumulated or the future value. You've got your T, which is time in years. Okay, so look at the formulas now. The formula for the simple discount, compare it with the formula of the simple interest. Okay, the one for the simple discount, remember we said the discount is calculated in the future value. This one, the interest rate, it is calculated in the present value, and you can see it's positive. Positive is an interest. Discount is negative. So those two are different. And then sometimes you find some text they are using this notation or that notation. It does not matter whichever way you look at it. It is still going back to the same themes. Okay, so what we are going to be doing here, we are going to be looking at the calculations that are looking at the simple discount. Okay, so another thing that you have to keep in mind, sometimes you can be asked to calculate a simple interest against simple discount. Okay, so should you, I'll see some of the questions that you can come across. If you are requested to calculate an equivalent, so you are given a simple interest and then you are asked to calculate an equivalent discount rate, this will be the formula that you use to calculate the, maybe you are given a simple discount and then you are asked to calculate the interest rate, you would use this formula. Okay, you are working between those two rates. Okay, I'm just throwing the theory here. Now let us look on the example whereby, I mean, the theory is what I've just discussed. What becomes a problem is when you come across the exercises, they talk something different. So now let's see the different kind of examples that you find. So the question here is saying, determine the simple discount. Okay, here you are asked to calculate the big D. Calculate the simple discount on a loan of 3,000. Remember, a discount, if you are looking, we are working with a simple discount calculation. The discount is calculated on the future value. So this one, it is a future value because we know what the simple discount, it is calculated in the future value, which is due in 8 months. You are given the time, but the time is given in 8 months. And then remember, if your time is given less than a year, you need to divide the time that is given with those units. So you need to divide your time with 12 because it's 12 months. At a discount rate, you are given your D. Your D is equal to 0.15. What is the discounted value? Okay. Remember, the discounted value from the theory is equivalent to the present value. So you are asked to calculate the present value. Okay. And also you are asked to calculate your simple interest, the equivalent simple interest. So there are two things that you need to calculate here. Okay, so now here, what you would do here, you would calculate your D. Okay, let's get the formula for your D. From the formula sheet, our discounted rate is equal to our discount, not discounted rate, our simple discount is equal to SDT. Okay, so this is equal to, okay, your S. You're also asked to calculate D. There are three things that you're asked to calculate. Okay, I've broken it down. You're asked to calculate the discount, simple discount. You're asked to calculate the discounted value, which is your present value. You are also asked to calculate the equivalent interest rate. Okay, so now your S there is equal to 3,000. You've got your 3,000, you multiply it by 0,15, and the time there is 8/12. So you're going to have 8/12. This is substitution, the power of the substitution. You find that the discount amount is equal to 300. Okay, that is the discount amount that you are asked to calculate. And then also the question is saying calculate for your P. From your formulas, you know that your P is equal to S minus D. Okay, so this is 1, this is 2. Okay, so your P, what is your S? Your S is given as 3,000. So you've got 3,000 minus, what is your D? You've just calculated your D to be 300. So this is going to be equal to 2,700. Okay, then you've got your, you get your calculation. Oh, you know, when I'm doing these kind of calculations, remember we've got different ways of thinking. We don't always think the same. Let's say you did not see it this way, when, or you can say, okay, fine. I know the formula for the simple discount, that the P is equal to S into 1 minus DT. That's another way. I'm just showing you another route. Okay, so my S, I've been given, my S is equal to 3,000 into 1 minus the discount rate, it is 0,15. The time is 8/12. This is one way of calculating your present value. You can plug everything into your calculator. You find that the answer that it is going to give you, you're going to have 3,000 here. 3,000 into 0,9, which is going to give you 2,700. Okay, so it does not matter whichever way you look at it, you will still get the same the same answer. It will just depend ukuthi which route that you prefer when to take. Okay, so we've calculated all of our components. Now for us to calculate for an equivalent interest rate, to calculate for an equivalent interest rate, remember we said the formula for equivalent interest rate, it is your R is equal to D over 1 minus DT. Okay, so your D then, your D is equal to 0,15 divided by 1 minus 0,15. The time you are using, the time that you are using, there is your T. Your T is 8/12. Okay, you plug in this in your calculator, you would find that your R is equal to 16,67. Okay, percent. Okay, so we have attended to all of the different variables. So with these calculations, what is important is to decontextualize what is given, break it down into pieces, get the correct formula, and then you substitute and do your calculation. Let us look on this one example. This example is saying a loan of 4,000 must be paid in 6 months' time. Okay, so now your time here is is given in 6 over, so you're going to have 6 over 12. Okay, a loan of 4,000 must be paid in 6. This is something in the future, so your S here, your S is just equal to 4,000. Okay. Your S is equal to 4,000. Okay, so determine the amount of money that you will receive now. If the simple discount is 18%, so now you are going to have your simple discount, which is equal to 0.18 per annum is applicable. Okay, this question is asking us to determine the equivalent simple interest, a simple interest, which is your R, the rate. Determine the amount of money that you will receive now. So now you are asked to calculate for your P. Okay, so I have pulled everything out, and then what you need to do now is to feed this thing into your formula, doing the same calculation. Most of the time people would struggle with converting your time to 6 over 12. Okay, so I'm not going to do the formula right now. I'm going to look for other examples, and while I am doing that, um, this is for equivalent. I don't want to do this one. I want to do this example. So you've got this one, which is saying Nola invest 15,000 in an account earning 6.57 simple interest. The balance in the account 6 months later, this is still the same thing. Um, our T here, okay, you've got our T is equal to 16. It is months. You need to divide this thing by 12, and then you've got your interest rate. So your interest rate there is equal to 0.0657. And then Nola invest, look at the English. Nola invests this amount, which is P, is equal to 15,000. This is simple interest. Uh, so here, what you do here, you just take your formula, which is S is equal to P into 1 plus RT. Okay, I'm not going to do the full question because I'm looking at the time, because I also want to do the compound interest. So here you just substitute everything, and then you are good to go. Here a bank's discount rate is 12%. So here you are given your D is equal to 12%. You need to pay the bank 5,000 in 6 months' time. So you can see just from the English that your S is equal to 5,000. And then in 6 months' time, so your time is equal to 6 over 12. You divide by 12 there. The amount of money that you will receive now from the bank. So here you are calculating for your P. Same thing here. You get your formula. Your formula would be equal to your P is equal to S into 1 minus the 1 minus dt. Okay, so now these are different aspects. This is a simple interest. This is a simple discount. So you plug in everything for you to be able to get the to get to your present value. Let us look at this one. Here you are. It's also a simple interest. Okay, it's also a simple interest calculation, and in an investment of 2,000 accumulated to this. So now you've got your P is equal to 20,000. and your S is equal to 45,200. If the applicable simple interest rate, so your R is equal to 0.12, then the time. So here you are asked to calculate the time. You have decontextualized everything. You can just get your formula, and then your formula is equal to S, which is equal to P into 1 plus RT. Okay, you substitute everything and look for the calculation which gives you the time. Okay, so this one is for the equivalent interest rate. I want to get, okay, here is another one that you'd find. You'd find it, maybe it can be a little bit challenging, whereby you need to calculate. Okay, um, here you are given this. You are given Gina invested 25,000 on 5th of March. Okay, so now you get your timeline. This is one of those cases whereby you get your timeline. You've got 15th of November. Okay, and then you've got your 5th of March. That's when you started. Okay, so now your present value here is equal to 25,000, and then the interest rate, your R is equal to 0.0876. Okay, the accumulated amount, so they need to find this thing. So what is challenging here? You are not given the time, but the time is given. But the time is given implicitly. Okay, you are given 15th of November and 5th of March. So you need to calculate the number of days between these. Okay, so to do that, you can just use you can go to your online calculator, go to Google, and then ask it to calculate for you the number of days between 5th of March and 15th of November. Or you can do it by inspection. Do it manually, okay? And then you can get the number of days. You'll find that the number of days between these, okay? So you've got 15th of November, okay? You've got 15th of November and then minus 5th of March. You find that the number of days between these is equal to 255 days. Okay, you're calculating using the calendar dates. Okay, so now you've got days. That means your time here is going to be 255 divided by 365. The emphasis here is for you to be able to convert. Okay, be able to convert between if ever you have the days, know that when you've got days, you divide by 365. Okay, let's see what is interesting here. Aziz urgently needs 10,000. She agrees to give her this amount now to be paid in the bank 7 months. And now based on the bank simple interest rate, so this is a discount rate situation. It is 16.4. The amount she will pay back equals to. So in this instance, you need to know what is it that is given. She needs a money right now. Okay, so she needs it right now. So now this is the present situation. That's how she feels. She is needing it now. That is the present feeling, which is the present value. Okay, the bank agrees to give her this amount now to be paid back in 7 months. So your T here is equal to 7. Because it's given in months, you divide by 12. Okay, from now, based on a simple discount, the amount she will have to pay back, that is your accumulated amount. Okay, so you decontextualize everything and then put it back into your formula. Okay, I want to look for the questions that that are attending to let me see the question. I want to go to simple interest. I want to do simple interest. Let us do compound interest because there are interesting questions that I'll come back to some of the questions that I have here. Let us look on compound interest because that's what I promised to do today. So with compound interest, this is the kind of situation that you'd find. Okay. Compound interest, you need to know what is compound interest and also the interest rate. Everything is positive. And then with compound interest, with you don't need to, you can worry about odd periods, we'll do some odd periods. You don't need to worry about this. Continuous equation value is important. The comparison date is important. The effective and nominal interest rate, it is not explicitly expected of you, but I'll touch on it just for your own knowledge. And then the compounded amount and the compound interest. So the misconceptions are the same, whereby it is the use of an incorrect formula, it is substitution, it is calculations, it is translating from word problems to mathematical expression, compounding periods, effective interest rate. That's what is problematic about compound interest. So we are going to be looking at compounded amount, principal amount, interest rate, and the time, and use the timeline to break down the stories. Okay, so the formulas that you find for compound interest, okay, you find this basic compound interest formula. However, this is a very interesting question, not an interesting, it is a formula that we encourage that you use because it is taking into consideration the compounding periods. And we are saying now, if the interest is paid, okay, biannually, that means you've got your compounding period of 2. If it is semi-annually, the compounding period, it is 2. If it is compounding quarterly, your compounding periods, it is 4. If it's compounding monthly, your compounding periods, it is 12. If it's daily, your compounding period is 365. If it is weekly, your compounding periods is equal to 52. Okay, so now here are the formulas that we use. This is where we start off. We start with this formula. However, going forward, because we are talking about compounding periods, this is the formula that is useful for compounding periods, for compound interest, whereby your M is the number of compounding periods, your M is compounding periods, your T is your time. Okay, your interest is your future value minus your present value. It has not changed from your simple interest. Okay, now let us look on the examples that are looking at the compound interest. Okay, so here you are asked to find the compounded amount on this one. Okay, the compounded amount, remember, is another synonym for your S, that means your future value. On this amount, this is your present value that is invested for 10 years. Your T is equal to 10, and then your rate is 7.5 per annum, compounded annually. So when we are saying compounded annually, it means your M is equal to 1. That is annually. Compounding period is 1, and then your interest rate here is equal to 0.075. That's how you write your 7.5. 7.5, it is just equal to it is just equal to 0.075. Okay. So now you've got everything there. You are using the compound interest formula. Why you are using it? You see that is compounded. The minute you see compounded, you use the compound interest formula. So your P is equal to 1 plus your I over M to the power MT. Remember, we said this is the formula that we are going to be using. So your P, this is equal to 5,000. Your P is equal to 5,000 into 1 plus your interest rate. It is 0,075. It is compounding annually, hence your M is equal to 1. And then you've got 1 multiplied by 10. You plug everything into your calculator, you are going to get your 1,103.05,16. Okay, so here we have applied the simple basic formula of the compound interest. And then how much interest is earned on 9,000 invested for 5 years at 8% per annum and compounded annually? I think this question is similar to the one that we've just done. So how much interest? That means they are not looking for an interest rate, but the interest. You are looking for an interest that is earned on. That means your P is equal to 9,000 invested for 5 years. So your time is equal to 5. At your R is given as 0,08 compounded annually. So your M is equal to 1. So this is a compound interest formula. So you're going to have your S is equal to P into 1 plus I over M to the power MT. So you've got your you need to find your S first. So you've got your 9,000 into 1 plus your interest is 0,08 over your M is 1 multiplied by 5. Okay, you plug this thing into your calculator, you will get 132.93,95. That is your S. Remember, what is your interest? Your interest is equal to S minus P. This implies that with your S, you're going to have 13223.95 minus your P is given as 9,000. So you are going to get your interest, which is 4,223.95. Okay, let us look on the question whereby we are looking for T, whereby we need to apply our logs. Okay, so let's see example 4. Okay, I am not going to do example 4 because I am looking for an example whereby we're going to be applying the logs. Okay, I'll just break down this into components and then leave it something that I think you can readily do it yourself. 1,000 is invested, so now you've got your P is equal to 1,000 is equal to 1,000. It is invested for 1 year. So your time is equal to 1 at 8% per annum. So your interest rate is equal to 0,08. But the interest is compounded semi-annually. Remember, semi-annually, that means it is compounding twice per year. So your M is equal to 2. How much interest is earned? So you need to find your I. So here you use your formula. Your I is equal to P into 1 plus I over M MT. So you are going to have your 1,000 into 1 plus 0,08 over 2 to the power 2. Your time is given as 1. This is multiplied by 1. So you get your answer there. Okay, so let's say you've got different scenarios here. These scenarios, you are asked to calculate the accrued principal if the interest is calculated yearly. So here your M is just going to be equal to 1. Here, half yearly, your M is going to be 2. Here, quarterly, your M is going to be equal to 4. Daily, your M is going to be equal to 365. 2,000 is invested. Your P is equal to 2,000 at a 14% interest. So your interest is equal to 0, is 14, and then your time is equal to 3. Okay, so your formula is S is equal to P into 1 plus I over M MT. So now you can manipulate this for 1, for 2, for this one, and get different answers. I've just done this thing so that you can see you can see how you would you would put the compounded period. My interest is where we have to look for Ilento. Here is another interesting question. Okay, so here we are looking for the present value. You've got the present value here that you need to look for. If the compounded amount of, that means your S is equal to 10,000, okay, is invested at 18%. So now you've got your R is equal to 18%. For 5 years, your time is equal to 5, and the interest is calculated monthly. That means this is compounding monthly. Okay, so now your formula is going to be S is equal to P into 1 plus I over M to the power MT. So your S here is 10,000. You are looking for your P, 1 plus your I is 0,18. This thing is compounding monthly to the power 12 multiplied by 5. Okay, so you are going to have your P into, you have your thing which is 1 plus 0,18 over 12 to the power 60. So this is 10,000. Okay, so now to calculate this, you are going to have your P. Okay, your P is going to be equal to 10,000 into 1 plus 0,18 over 12. You get an inverse of, or the inverse of this exponent, which is negative 60. So you plug into your calculator, you find that your P is going to be equal to, what is the value of the P? It is 4092,96. I want to do a question whereby we are looking for the time. Why? Because it wants us to use our exponents. Okay. And I also want one whereby we are breaking down this thing in a timeline. So after what period of time? So we are looking for time here. Will 2.5 double? So you've got your present value is equal to 2.5. It would have doubled. That means in the future, this is going to be equal to 5,000. It has doubled in the future. If the interest is calculated, so your interest is equal to 0,11 and is calculated half yearly. So it is compounding twice per year because your interest is calculated half yearly. So you need to use a compound interest formula. So your S is equal to P into 1 plus I over M MT. You substitute everything into your formula. You're going to have 5,000 Your present value is 2.5 into 1 plus your interest there is 0.11 divided by this thing is compounding half yearly, and then you've got your M, which is 2T. Okay, so you need to simplify. So if you divide everything by 2.5, you will find that you are going to have 2. You divide both sides by 2.5, you're going to have 2 is equal to 1,055 to the power 2t. So here, this is where you need to get out of financial mess and go and ask help with mathematics. Okay, we go to algebra. We go to algebra and do analogues. So doing analogues now, we know when you are doing analogues, we know if ever you've got your y is equal to a to the power x. Okay? Using the logs are saying now your x, okay, is equal to the ln, the natural log of whatever you're going to find this side, divided by the natural log of the base that you started off with. Okay, that is algebra. That's an algebraic property that you would apply when you've got an exponential equation. Okay, if you were to do that here, we are saying here your 2t, that is your exponent, which is your x side, your 2t is equal to the natural log of whatever you find here divided by the natural log of the base of what you started off with, which is 1,055. Okay, so you plug this thing into your calculator. Your calculator can give you a fraction whereby you press ln 2 divided by ln 1,055, and after you've done that, you divide by 2. So after you've divided by 2, this would imply that your t is going to be equal to 6,47. So what is critical in this question is when you get an exponential equation, okay? When you get an exponential equation, you apply this principle of natural logs. You get out of financial mess and go and attend to issues that have to do with algebra, and then you do your algebraic simplification so that you can get your answer. Okay, I want to look for an example whereby we break down, we need to apply timelines. Yeah, so here is an interesting question. I got this question from somewhere, and one of the classes that I had was like, hey, we don't, I mean, the context, I cannot relate to this context because Tina, we don't buy my paintings. I can never buy a painting at 15,000 in it. Never. But let us assume you are Solkers now, you've got this money, you want to buy these paintings. Yeah? So you go and invest. This is more like an investment. So now this lady Miriam bought a painting for 15,000. Yeah? That is the present value of the painting. Yeah? For 10 years, the value of the painting increased yearly by 20%. Okay, it has increased yearly by 20%. Thereafter, the value increased by 15%. Okay, so now there are two things that have happened here. Okay, it's not a straight investment. The interest rate has changed twice. Ne? It's not as if you are quoted only one interest rate. So you need to take all those changes into consideration. Okay. So now every change that is taking place in your investment, you need to capture that in the timeline. So then you can see what is happening in your investment. And then the amount of money that Miriam can expect to receive if she sells the painting after owning it for 23 years. That means the length of time of her owning this thing is 23 years. Okay, so for 23 years, that's the length of the investment. So this thing is so sketchy for us. The best thing is to put it in the timeline. So now you go and get your timeline and say, okay, this person is starting off, this is your first present value of 15,000. Okay, and then this thing, um, uh, she keeps it for 10 years. This is your T0. Okay, this is your T0 here. So this thing for 10 years, you've got now your T1, which is equal to 10. So now your investment from here to T0, it has ran for 10 years. So now your T here is equal to 10. Okay, so now it is going to accumulate a value. Okay, so this thing has got a specific interest. The initial interest that it is starting with, it is starting with an interest rate of, this is increasing yearly. So your interest rate is equal to, is starting off with 20%, 0.20, and it is compounding, increasing yearly. That means it is compounding yearly. That is your M is equal to 1. That's what happens with the investment for the first 10 years. Okay. Then we take a break and look and say, okay, fine. This thing continues because remember, you start from T0 and then you are running until T13. So this is your T13. Your T13 is the total time of 223, by the way. The total time of your investment, it is 23. Okay, total time of your investment is 23. Okay, but within these 23 years, you do something, then after 10 years, the interest rate changes. That means now, if ever your investment has ran for 23 years from the beginning, something has happened already for 10 years, you are left with 13 years. So from this period until here, this thing is equal to, your T here is equal to 13. 13 plus 10 makes up the full 23. Something has happened here. This is your investment, your interest one. There's another interest rate here. You are told this interest rate is 15%. So you've got your 15%. Also, it is increased yearly. That means it is compounding once. That is yearly. So you've got your M is equal to 1. And yet you don't know what is your final investment price. You are looking for this because now we want to know how much amount that Miriam can expect when she sells the painting after owning it. We want the accumulated amount. So now we've got two parts. The reason why you've got two parts is because there's a disturbance with your investment. It was not a smooth investment that started with a specific amount until the end. There was a disturbance. What was that disturbance? The interest rate changed. So you need to pause also as the financial advisor. Pause at 10 years and say, okay, fine. What is an accumulated amount during the first 10 years? Then it is your S1. And then you say, okay, fine. From this amount, I'm going to start again because I've paused. I'm going to start again for the balance of the term. So now, the amount I'm going to start off with is going to be the amount that is going to be accumulated at this point. This is the breaking point. So the present value of the new term of the 13 years is going to be the accumulated amount from the previous term. So you need to do two calculations. Okay, so now let's do the first calculation for the first 10 years. Okay, so now the first 10 years, the calculation is going to be S1 is equal to, you've got S1 is equal to P1 into 1 plus I1 over M to the power MT1. That is the first 10 years. I noted everything as this is one is T1, this is T2, and given it a subscript. For first, I've given it 1. So the P1 you are given there is 15,000. You've got 15,000 into 1 plus the interest rate there, it is 20%. And then this thing is compounding annually. This is going to be equal to 1. 1 multiplied by the first dento is equal to 10. Okay, I plug this thing into my calculator. I find that my accumulated amount here at this point is going to be equal to 92, okay, 876, okay, 0.05. Okay, remember this is my S1, and according to my N1, to my timeline, my S1 is equal to, is also the value of my new present value, the second term. Okay, and then I said, okay, let me get the accumulated amount at S2. So at S2, I'm going to be having P2 into 1 plus I2 over M to the power MT2. I am only calculating for the second part, right? So I know what my P2 is the same as the previous accumulated amount at this point. So this is going to be equal to 92876,05 into 1 plus the interest rate for this little nyana period. Okay, it is 0.15, and then I divide here. Your M is equal to 1, so I'm going to have 1 here, and then I am going to raise this thing to 1 multiplied by T2 is not 23, guys. This thing has took a pause. So I need to get the calculation per period. So this one is going to be equal to 13. Okay, so here I'm going to have 13. Right? Then I plug everything into my calculator. After I've put it into my calculator, my S2 is going to be equal to 571,446,59. Okay, this is a derivation, guys, of the formula. Why I have broken it down into pieces, I want you to see when there is a specific disturbance somewhere, something needs to change. However, there is a shortcut to this. Once you understand how we came to the general formula, you can say that for you to get your S3, okay, your S3 is none other than your first present value. It is equal to this, okay? It is equal to the amount that you would have got. It is going to be equal to this value, okay? multiplied by this part. Okay, so basically it is going to be this. So you are going to be having this amount of S1. So this is going to be your S1, okay, multiplied by this, okay, multiplied by this part, which is equal to 1. What is your S1? Let us write our S1. All this part, it is going to be equal to P1 equal to 1 plus I1 over M into MT1 multiplied by this part, 1 plus I2 over M to the power MT2. So now you find that some text, they just take you straight to this generalized formula. There's a danger of using generalized formulas without understanding how they were derived. So that's why I have taken time to show you how this formula was derived. It is derived whereby you are starting off with your first 10 years part, and then you finalize with your last part. Why? It's important for you to get an answer as 571 and not add this, because what I've found is when people have calculated, I'm sorry, when people have calculated your S2, they go and say S2 plus S1. It does not work like that. Remember, when you calculated your S2, you've already taken the accumulated amount of S1 into consideration. Okay, you've already taken it into consideration here. There is your S1. Remember, you said your S1 is equal to S2. So there is your S1. It's already been taken into consideration. So if you are going to be adding it again, you are creating what we call the circular argument. Okay, the circular argument is when you are going around the cycles, you don't get out of the loop. Okay, so if you are going to be using this procedure, what you find here is your final answer. Okay, or you can use this shorter version. That means if you can remember this formula. Okay, if you remember that I'm starting off with my present value, and here I'm just going to be multiplying my interest rate as per the times. If there's a third period, I'm going to multiply the interest rate part of that, and so on and so on. Then it's fine. As long as you understand where is this formula coming from, it is really not a problem. Okay, I was just taking you through on how you derive this. Okay, having said that, this is what I have prepared for you. There is more that we can discuss, especially about the compound interest. We'll be doing more of compounding interest when we are doing amortization and annuities. Compound interest becomes critical. I think that's all I have for you. I shall see you definitely next time, and it's going to be productive because it's going to be attending to the agent questions that are related to the assignment that you are going to be submitting. Thank you very much.
Bye.
Bye-bye.